Yeah, like I said, those of you who took this course with background and interest in STEM, for example, computer science, engineering, etc., would have to think more about the societal impacts kinds of scenarios that you probably wouldn't care about in doing your exams normally. But the opposite would be true for those of you who took this course coming from humanities background. So you anyway would think about societal impacts. So I want you to get a little on the technology part because you need both. Because if you don't actually know what is the technology, at least at some level, then you are not going to be any different from self-proclaimed AI experts that are a dime a dozen these days. And so I would, the few of you, those of you who have like the humanities background, you will have to get through a little bit of understanding of how some of these techniques work. So that's what that 3 blue, 1 brown is. Normally, I'll try to do that at the second part of the class so that you get to talk more discussion, etc., that you wanted to do based on the readings. Does that sound okay? Okay. So then take away anybody who has anything that they wanted to bring up on what they read.
I'll start.
Okay.
I thought it was interesting how it talked about like how there were disproportionate like false recognitions of people of color. And so I guess I just want to learn a little bit more about how specifically like the AI programs are programmed to detect people of color and why they disproportionately like misdetect them. Because I like went to the like hyperlinks that were in there, and I didn't necessarily understand this like specifics or what they were trying to talk about or explain.
Okay, so did anybody else want to answer that based on their understanding?
From my
Yeah, I can
understanding,
try. Oh, sorry. Go ahead.
I was just going to say, from my understanding, the camera has a difficult time detecting features on darker faces, especially on darker backgrounds. Other than that, I'm not quite sure.
No, that's actually not the issue. It's more than that, but go ahead.
So what I thought was the main problem was that it's using the data available online. So it was talking about how there's usually more data from Western societies, and that's usually like white people, and so it's trained more with those faces rather than people of color, and so it's not able to kind of match those features to that.
That's actually very much the reality. So I don't know if I wrote this in the article, but Samsung some years back had this camera feature which would do blink detection. I don't know whether I told you this or whether I already written this. So it would do blink detection. So if you're taking a portrait of your friend and right at the time when you are about to take the picture, they blink, the picture won't come well, so you have to remove it. So what it would do is it'll say, if it actually detects that they blinked, it will say blinked. And so that you take another picture. Okay, sound like a great idea, technology helping us, etc., etc. And then somebody pointed out essentially that it always kept saying blink, blink, blink. That means the person is blinking for anybody from China, Korea, Japan. Now, it's so easy to say, obviously, Samsung is a racist, biased company, but you guys know that Samsung is from South Korea. Do you understand what I'm saying? It's not like they're not going to be able to survive by making fun of their market, right? It was because they essentially used the easily available data, and the easily available data wound up not being good enough to tell whether there is a blink for, all, all races of people. Do you understand what I'm saying? Okay, it's just a question of, so this was not even really high level AI, right? I mean, it's not like a particularly sophisticated AI. It was essentially, presumably, doing something extremely low tech, such as how big is the eye area compared to the face. That's it. But we know that that actually is already biased because it's, you have that ratio depends on whether you are from, like, Caucasian races versus Asiatic races versus some other thing.
But didn't it also say in the article that POCs were more wrongfully like convicted as a result of?
No,
like, more
yeah, okay, so yes, that very, very different reason. So there are basically the thing that is common. Let me actually see if I can get my notes up so that I can write something once in a while. Give me a second. And then I need to also zoom. Give me a second. Whatever. So, okay, I will need to take some time for this. But so what, it's ultimately a question of data that you are training. So there are two ways. You can either tell the system some explicit knowledge that you have about who is a criminal versus who is not a criminal, okay, or who has a eye blinking versus who doesn't have an eye blinking. That is explicit knowledge. The advantage of that is when you actually read the program that guy wrote, then you will say, my God, are you crazy? This is not the way to define criminality. Because, it may have been okay, in the dark ages when we didn't have a reasonable sense of fairness, etc. But now we are much better off, and we shouldn't be defining criminality, etc., based on surface features. You would never write it yourself. A program, nobody will write a program like that. But on the other hand, people might just give collected data to a system and let it interpret and find patterns in it. Do you understand what I'm saying? So in the case of things like criminality detection, etc., it was, unfortunately, it was because the data was taken from the world that we live in, and for its own structural issues, the world that we live in has already compromised data. Okay, I mean, you should not be surprised, and if you are, you should read something like New Jim Crow. How many of you read New Jim Crow? Basically, most of the prison population in the United States is, it's like a substantially higher majority of the prison population with respect to their actual percentage in the population is African American. And there are very complicated reasons for that. Many of you probably have thought about it. You can read about it. But they're very complicated reasons having to do with how the society came to the point it currently is, including slavery and Jim Crow and everything, which is why actually, that book basically says New Jim Crow is, one of the ideas is actually putting people behind the bars is a way of dealing with bunches of things. And now, if that's where you are and you got the data from there, then you are likely to find patterns. I mean, the machine is likely to find patterns in that data that you didn't want to admit to yourself explicitly. Do you understand what I'm saying? Which is why actually at the end of that article, I had this thing that sometimes an AI system can put a mirror to the society, because oftentimes we don't admit to ourselves what is actually happening in the real world, because that will make us very uncomfortable, right? So by actually showing you the statistics and learning patterns from that, you might be surprised that this is basically what apparently are the, the characteristics of people that, the faces that are being subject to various kinds of things. So there is that aspect of it. I don't really want to dwell on that too much, but that's an interesting aspect too, because if you haven't thought about, if you assume that the world was not biased and the AI was biased, then you need to understand this.
I have a question.
Yes, please go ahead, Peter.
One of the things you talked about in the article was balancing the data manually, and like, for instance, one of the things we talked about is facial recognition, predominantly having white people in the training set. But you didn't seem to think that manually balancing it was a good idea. Could you go into some more detail as to why that might be?
That's actually a very good point. Let me see if I can get my notes. I feel naked without writing something. I mean, that's what I guess. I'm not really a humanities person. I need to write something once in a while to feel as if something is happening. Let me see if I can get this. Okay. So let me try to repeat the question as I understand it, and then I'll try to answer it. So I think this is what Peter was asking this question. Okay, so I think what we were saying is that one issue, actually let me ask other people if they have any comments on that, because that's what I've been told. And I think it's a good idea, because these things, many other people have some idea too. So I'll repeat his question, okay? And then you can see if you have an idea. So one way of ensuring that the systems don't get inadvertently biased representations in terms of the examples that they're getting, is to make the data set be balanced, right? So for example, in the case of Samsung, it should have taken it should have checked whether its algorithm is working for people in the Midwest in the United States. It anyway did that, but it should have also checked whether it's going to be making sense for every place where it is trying to sell this camera. They just did not do it. Do you understand that? And so in some sense, so there is a difference that, so basically, if possible, so in some sense, what I'm saying there is, when possible, you should get a balanced data set. I mean, a data set that is actually representative of the world, rather than the data set that you just happen to be easily picking up. Okay, that's fine. But I think Peter picked on something that I did intend to communicate, which is that finding a more balanced representation of the world versus balancing the data set, leaving the world as it is, are two very different things. Do you understand what I'm saying? So for example, if you now go to Google, and I think I might have mentioned this before, type engineering professor in the images, you will get pictures of people who have been recognized as engineering professors on their web pages. Most of them will be male, most of them will be balding, most of them will be white. Right? So now you can balance the data set in two different ways. One is change the world such that the world actually has a more balanced set of engineering professors. Non-balding males would be a good step, right? So that there'll be a more diverse set of engineering professors. But changing the world is hard. So the much simpler idea is to just basically pick the data set such that you amplify the number of non-male balding people in the data set. Did you understand what I'm saying? So essentially, this is the kind of thing, in case you haven't realized, this is the kind of thing all the universities and all the companies do to show that they have diverse workforce. Right? Basically, they will pick and choose a good set of diverse subset, a huge set, which is biased 99% white and 1% black, can still have a small subset, which is 50-50. So I'll take pictures of that and put it on my web page. Right? So what I was worried about essentially is this second aspect, where in essence, when you are doing that kind of a balancing, then you are sort of doing societal engineering. Except you are not doing societal engineering on the society, but on just the data. So it's a second order question as to how, you could get into a situation where you can pat yourself, on your back saying, my AI systems basically seem to be thinking that everything is fine with the world I'm living in. Okay, so at least that's the kind of thing I'm getting at, because in some sense, when you are changing the data set, you, the engineer who is training this machine learning system, is doing societal engineering, social engineering, except not on the society, but on the data. Okay, if you want to do social engineering, and if you want to allow people to actually comment whether or not this is reasonable social engineering, you should have the guts to do it on the society. By the way, it's a funny thing that somebody pointed out, that social science is a good phrase, social engineering is a bad phrase. It's one of those things you can keep in the back of your head. Why? Obviously, so social engineering somehow means there is this some calculated way you are sort of, some despot is trying to change the natural order of things. Anyway, that's the kind of thing that I was trying to get at, Peter. I don't know whether that,
Yeah, that makes sense.
I don't know, bouncing off that point, just like as thinking about going into the research field myself, when I hear like cherry pick data or like use specific data sets that aren't like random sampling, that always like makes me nervous. And that in my opinion, like if I heard, oh, all the data from this article about the new vaccine was like cherry picked, I'd be like, well, throw out that article. Like, this should not be published. This should not be peer reviewed. Like, this is bad science.
Yeah. See, that's my point. But the point is, to some extent, so the idea is, if you want the system to train on minority samples, you do need to get the system get more exposure to those samples. And when you do that, you are kind of playing with the data set. And so it is cherry pick data set. So it's a new kind of a problem you have. I mean, actually, there's one of the interesting things is the sensitivity of the world around us has increased right at the time. I mean, there was a good old days, quote unquote, when if it's good for white balding males, it's good for everybody, because we are not asking everybody whether it's good for them or not. This basically, they don't have any voice. Right now, because of all these nonsense things like Twitter, etc., people actually speak up that they're being ignored, right? And so I don't know if you noticed, there are this amazing stuff on the Twitter, etc., where this African guy would try to put his hand under the faucet. These are these faucets that try to see if there is a hand, and then they'll open the faucet. He'll be doing this. He can dance for all I care under the faucet won't come on. Then he will take a white towel, put it on his hand, put his hand under the faucet, the water will come. How come most of you didn't see it? Because you didn't have to. Most of you, if you only have a white skin, you wouldn't even have seen this failure. Okay, and the people who did see the failure previously used to think, it's okay, I have to live with this. But now people can vent. People actually can tell you that system isn't working for them. And into that mix comes AI trying to learn from the data. And so we are a lot more sensitized about it. Go ahead, somebody was saying something.
Yeah, building off what Catherine was saying, I guess how would you be able to allow the AI program itself to learn from the society around it, so that it can function for minorities and POC while still having an accurate representation of the society, right? Because
again, I think all I was saying is that ultimately you do have to do data set engineering, but you should be careful when you're doing it. I mean, there should be some thought put into it, and people should be agreeing that in this particular case, this isn't going to cause any inadvertent problems. Okay. So in the case of the gender shades project, that is the one that I was mentioning that was mentioned in the class in that. Okay, I'm finally got into this. So the gender shades project, essentially, in that case, there's nothing whatsoever wrong in getting a data set that is more representative of all the people in the world. There's no downside there. Do you understand what I'm saying? Of course, it might actually reduce accuracy on one subclass. That sometimes it can happen depending on the way that the actual training is made, but at least getting data that is representative of the faces of all the people in the world, United Colors of Benetton, for example, would be a very reasonable thing to do. I can't see what's the downside of it. And the interesting thing about the Gender Shades project is up until the time Joy Bulavami and I believe it is Timnit Gebru have shown that commercially available gender recognition systems from Microsoft, Amazon, IBM, etc., they were basically pretty darn bad in doing something as basic as gender detection, not even identity, not even, who are you per thing. It's like, are you a male versus female? Again, that itself is an interesting issue. But assuming for now we are talking about something like male versus female as if it is binary, even that they were unable to do. especially if the photos were coming from non-Western societies. So, and why did people not recognize it? Because you train a classifier, you test it on a test set, and if the test set is also full of Western European faces, you don't see any problem. That's the same reason why people don't see the problem of the faucets not working for Africans, maybe, or people with really dark skins. If in fact, most of the people in that building wind up being fair-skinned people, then they don't see any problem. So the only way to check is to actually have a test set which is representative. So in the gender shades project, interestingly, they came up with a data set called the parliamentarian data set. Okay, and so what they did was they took, it's hard to, so basically went to all the countries of the world, and everybody has a government. So they will have like legislatures, some senators or whatever they might be calling in those countries. So they took pictures of those people and made the test set. And they basically know the labels for them because they would, those, those websites would have probably told you whether they consider themselves male or female. And they then gave this to this Amazon and IBM websites and the systems, and they found that they were pretty bad. But the good news is after that work, now these systems, the Amazon, etc., are actually much better. Okay.
I have a question about like going
Go ahead.
along what. So I can understand like why balancing the data is bad for like the data regarding the balance of professors and stuff, but with programs like face recognition, isn't it like better to balance it still? Because
yeah, I think that's fine. I mean, my sense was balancing the data for face recognition is, I think it's completely fine. Again, all I'm saying is you cannot just play with the data without thinking of the bigger ramifications. So the fact that we actually decided here that if you're only interested in correctly recognizing the face, training yourself on a full diverse set of data that's actually naturally available, and you are basically looking at the full set of data as again as basically a one which is biased to look at a subset of the data, maybe the Western faces. That is obviously fine, right? Other points? Yeah. Again, by the way, it's hard for me to look at the chart as well as talk to you. So anything that you put in the chat, if you want me to, if you want me to get to it, actually say it. When you can write it to remind yourself, but when I say other points, then bring it up. That might be simpler. I mean, feel free to keep writing on the chat. It's actually good, but just don't assume that I would look at the chat, because I can't do that as well as look at my iPad, as well as look at the chat. That would be hard.
Yeah, this was from a little bit ago, but what's like some examples of like social engineering on society?
Social engineering on society. So let me see if I can get that. Yeah, let me see if I can do this. So the example for that would be one example that I'm familiar with is the engineering professors database. Then I'm going to show you a picture of that in a second. Basically, again, it's a slightly different scenario. It's not just it is not just a so we were doing this work where this is actually connected to something else. Let me try to explain that too. So we were doing this work where we were trying to talk about practice of data augmentation, which is this something people do these days, which is if you don't have enough data, then you make the system dream up more data and use that to train the system. So sometimes these ideas work fine. For example, the usual kind of data augmentation idea that people do is imagine you are trying to make a, let me write this data augmentation. Suppose you're trying to train a system to recognize cats. Okay, and suppose you only have 100 pictures, photos of cats. I know that really there's no dearth of cat pictures in the world, but act as if there are only 100 pictures of cats that you found, right? Now, it turns out that, as we mentioned last class, many of these systems, basically, there is a huge network which is basically going to predict the class. And they are putting the image here. And there's a network of neurons connected to weights. At least that's the currently working idea. And all these weight parameters are learned automatically so that you will be able to say, if you're shown a cat, it'll say cat. If you show a dog, it'll say a dog. But it requires a humongous amount of these pictures. One idea for data augmentation is, if this is a cat, I can't draw a cat, actually, let's suppose it's a cat. It's not a real cat. But if I then essentially crop the picture, it will still be a cat. For most reasonable crops of the picture, it will still be a cat. Any rotation of a cat picture is still a cat. Do you understand? It may be a little harder for you to figure out, but just because I picked your cat and put it upside down, you may get mad at me, but you would still realize it's a cat. Right? So if you do this, actually, it's increased the amount of data available. So you started with 100 cat pictures, then you got another 500 with 5 different, for each picture you did 5 different crops, and that will be 500 new pictures. And for each picture you did 6 rotations. You got 600 rotated pictures. They're all cats still. Because we agree they are cats. So this idea is called data augmentation, and it is used to basically to deal with cases where there is not enough data. Cats obviously are not a big problem. Now, a place where, in fact, this is actually important is using X-rays to detect particular kinds of rare diseases. The reason they're rare, the fact that they're rare means that there are not that many X-rays that are available of people suffering with that condition. And you still need large number of examples of how to to present it to your system. So in those cases, actually people have used data augmentation. Now, this is a circular way to get to the point that I'm trying to get to, which is that sometimes when you do data augmentation, it's not completely clear whether you have changed the data. In the case of cat, it was quite clear. Right? In the case of cat, it was quite clear that basically the things that I was doing is changing its orientation, etc. But there is a whole entire type of technology that we haven't talked about called GANs, which is generative adversarial networks. And what they do is they don't just classify, but they can provide an example too. Okay. And the idea is when I say cat, you kind of, in your mind, think of an actual cat picture. Okay. So you dream up a cat, right? And so in fact, the systems, that neural networks can be made to dream up new cats. When did we first see this kind of a thing? In this class, something like this we did in this class. I showed you examples of this.
So the faces that were generated?
Exactly. Where did those faces come from? I told you these are the faces of people that don't exist. That's not a classification problem. That's a dreaming problem. Now, if you have the technology, you can generate any number of faces. I mean, if you have technology for dreaming of faces, then you can generate any number of faces. So that winds up becoming a new kind of data augmentation technique. Do you understand what I'm saying? So I see a few examples and I'll make up more, I'll dream up more examples that look like this. If you are doing that, in some work that we did, we basically looked at the photos of engineering professors and then train a GAN, make up new engineering professor faces. Okay. In that particular case, there are two issues. One is, of course, if all you have seen in your entire life were male balding whites as engineering professors, when I first say engineering professor, that is the picture that comes to your mind. You don't need to admit, but that's what happens to most of us. Okay, because your imagination is sort of impoverished imagination because you have not seen examples of other types of engineering professors. So if you basically do this kind of new generation, one of these other things is you do notice that all these made up, glamorous faces that I showed you that day, the first 5 look maybe better than us, and it looks nice. My God, I mean, those 5 look better. But if I can generate 1 billion of them, you'll get sick and tired of them because they all look basically sort of kind of like some combination of the existing Hollywood actors. The world at large has more interesting faces than just those faces. Do you understand what I'm saying? So if you augment data that way, then actually what you are winding up doing, in the case of Hollywood, you're just saying the new Hollywood actors will always be looking just like the Hollywood actors of today, because that's the database that you started to dream on. Okay, in the case of engineering professors, you'll think that the new engineering professor things that you make up will be like the old engineering professors. And what we have shown in our work actually is that it's even worse than that. Because of some technical issues having to do with GANs, the minorities in the engineering professor database will become even more ultra minority in the imagined universe. Who asked me the question as to give me some examples of social engineering could be a problem?
Oh, I did.
Okay, so would this is a kind of a thing where I imagine more engineering professors this way, and I added it to the data set.
Gotcha.
Okay, then it winds up having all sorts of interesting issues, such as either it might perpetuate biases or it might even worsen biases.
Okay.
Again, all I'm saying is when you are changing the data set, if it is with respect to people, it's like you're changing the society without telling the society. Do you understand what I'm saying? And so if it is something that you wrote for your class project, it's not going to affect. If it's something that you're writing at an Amazon level and it's going to be used, large scale, then whatever random decisions you made in training your system are actually going to affect a lot of people in the world. And you probably didn't think about those issues at all when you quote unquote balance the data set.
Okay, thank you.
Okay. Yeah. Other questions? Yeah, I'm trying to look for the pictures of that. Okay. Other questions?
I don't have any questions. I just really like the way you said it's like you're changing society without telling society. That really made it click in my head.
I think, again, that's the interesting thing. If you just did it, I mean, we all imagine, basically when you're kids, you would play make-believe games. Changing the data that is going to test something that is a widely used system is doing make-believe on the societal level. And so that's where things come in. So anyway, so this is the picture. This was actually the pictures. I mean, this was not NVIDIA quality pictures. They all look like augurs because they were low res pictures of the faculties that Niharika and co picked up and then generated new pictures. You do kind of notice that they might look like augurs, but they look like male augurs mostly. Okay, do you understand what I'm saying? So that's not surprising. Okay, and so in fact, in this paper, what they wound up doing is to actually check whether it worsens the bias even inherent in the data set or not. Okay. I mean, you can actually make these pictures a lot better. If you train on high risk things, but then what we consider as male versus female, etc., is not going to be. The real question is whether the data set is going to be any more biased or equally biased than the original one. Other points? So the other thing that actually I was going to mention last time that is worrisome is of the many cognitive biases that we have, I mentioned cognitive biases, right? For example, when I'm trying to sell you insurance for all untoward accidents that can happen when you're on the plane versus insurance that takes care of terrorist attacks when you're on the plane, you go for the terrorist attack one, even though that one is a subset of all the bad things that can happen on the plane. Do you see what I'm saying? For the same price, you're likely to buy something that is actually a subset. And so these are all our irrational thinking. And so the problem in the case of AI systems with respect to working with humans is humans have this other kind of a bias called automation bias. If the machine said so, I believe it. So we almost stop thinking for ourselves, and if the machine said so, I believe it. So there is actually, in the case of that criminality, the Broward County compass system, North Point compass system, which I mentioned also in the article, that was a well-known case where basically ProPublica did a study on that system. That system was being used. And ProPublica did a study on this system and found that it is basically finds African Americans. So it was supposed to be used, this compass system was supposed to use, it was used to decide whether to grant bail. For someone who was brought to the court. Okay, and basically this system will take some features of this particular case and will make a recommendation. And the judges were basically, the original argument is that the judges all said, look, we actually think about the case. What this system says is just one of the many things that we take into account. So you don't need to worry about the fact that this system actually was not carefully vetted. But then they did an extra study and found that pretty much the judges always agreed with the system. Do you understand what I'm saying? So we all like to think that we have free will, etc., etc. But if the machine said so, okay, I'll think a little bit and I'll do what the machine said. Plus, if you're a judge and you have too many people that you're trying to decide whether to grant bail or not, you're better off actually to just let the system do all the hard work. And so that automation bias is something that winds up making many of these problems bigger problems than they should be. Okay.
So it's kind of like when you're taking a math exam or something and you have an answer that you put on your calculator and the calculator is wrong, but you look at it,
yeah,
you think it's right. Okay.
That's basically automation bias. We always assume that the machine might be right. I mean, it's again, all these cognitive biases, they're just more likely, if you prime people, they will, I'm hoping that first of all, nobody any longer buys insurance when they are flying, partly because nobody is flying anyway. But even if you are flying and buying insurance, hopefully you will remember because I've told you this. And so you would decide to, if you're crazy enough to buy insurance, you will say, take insurance that covers everything for the same price than something that only covers the terrorist incidents for the same price. But if I didn't tell you, you're more likely to have done the usual cognitive bias. That's the problem. Other points?
Well, I was just curious further on that study, because I'm just wondering if there's a way we could find out more information about the study with the AI and the sentencing, because I'm just wondering if the judges, once they had that system, did it represent a shift in how they sentenced from before? Because is it possible that the AI could also just be biased in the same way that the judges already were before?
So there's a lot of information about that. Actually, I believe in fact, put a link to the ProPublica article in the write-up I had. So that's a way you can read. So I'm not sure whether that answered your question. So in the case of compass system, actually, it turns out that it wasn't. It was, a system where this north point did hand engineered features. And there is a problem with the way they were hand engineering those features too. And to give you a sense of hand engineering in fairness and in making sure that things are done fairly, one simple thing that people try to do, and again I mentioned it in this article in passing, you may not have caught on your attention, is to say restricted variables. For example, you do not show some sensitive variables values. For example, you may not tell the judge about the race of the defendant. You may not tell the system about the race of the defendant. You may not tell the system about the annual income of the defendant. Do you understand what I'm saying? And if you do this, then you can nicely pat yourself on the back saying, look, I'm not racist. I am not against poor people. But the problem is, if you have, let's say, a defendant, and they have a whole bunch of features that you try to characterize them in. One is race, which we won't let the system know. Okay. And the other is annual income. That also you won't let the system know. Then prior convictions. That you think is a reasonable thing for the system to know, right? I mean, if you're a defendant, you would like to know how many times they were convicted in the past, okay? And you might write prior bail jumping incidents, etc., etc., etc. You have to take some features to decide that you're thinking about this particular defendant. And you feel that you certainly did not take any sensitive features because you didn't tell the annual income, you didn't tell the race. But the problem is there may be correlations. Correlations between variables. For example, one of the other things you might feel is a reasonable thing to add is the area where the defendant lives. That upfront, it looks like non-racist, non-sexist. I mean, how can your address be giving away anything? But in the world we live in, it gives away a whole bunch of information. Beverly Hills 90210, give the damn guy a bail. They can deal with $10 billion, bail, and they'll get out. Inner city, 3040, in fact, it may have other kinds of a correlation. So you basically, the interesting part is, if you think of a defendant in terms of this set of features, because they're a data point now for you, the features will have correlations. So putting your hand on some features and might give you a false sense of fairness. Thinking at least I'm not considering those features. but you may well be considering those features because the generating process, this is a mind-blowing idea. Let me see. Yeah, the generating process for the data has implicit internal correlations.
What does the fourth
What?
thing in the like essentially the list in the parentheses? It says race, armed with gun, prior convictions. What does the fourth one say?
Oh, what I wrote here. So I wrote race,
Yeah.
annual income, prior convictions, prior bail jumping incidents. That means after my assumption is, I'm not actually good at this. I have never basically been produced in front of a judge, so I don't remember what you're supposed to do. But typically, I may assume that if you are granted bail, then the idea is you put some money and then you are supposed to come back to the judge to be sentenced or to be tried at a certain date. You know, the usual bail jumping typically is you'll pay the $10 or $10 million and you skip town or skip country. That's a reasonable thing to know. You know, if last few times I made a mistake of giving Rao bail, he never showed up. So this guy should not be given bail this time. So that's one of the other things. That's what I wrote, prior bail jumping incidents. And then the other one I wrote is the area where the defendant lives. So one of the strange things that is actually going on in AI right now in this aspect, this is really, as I said, these are systems that can be used for things that don't affect people, such as is it a cat or not, or is it a cute cat or not. You know, you can use your classifier to just talk about whether your cat is cute or not, and it's not going to cause major damage. I mean, if somebody said your cat is not cute, you might feel a little bad, but that's okay. But it can also be used to say, should they be given bail? Should they be given the loan? Is this credit card transaction fraudulent? Is this person in the wrong neighborhood? Based on, I mean, that's what is this whole issue of what black while driving, driving while black, etc. Right? Because people already have these kinds of biases in their head, and the systems can help them perpetuate them. And so this has become a lot bigger issue. There are multiple conferences. One is FACT, which is Fairness, Accountability, Transparency. And that's one conference. The other is AIES, AI, Ethics, and Society. These are conferences that look at some of these issues. And as a cute digression and FACT, you started with FAT, Fairness, Accountability, and Transparency. And it was FAT for quite a long time. And then somebody started complaining, saying you cannot call a conference about good things in society FAT, and that's sort of fat shaming. I'm not kidding. So then they actually put a small c inside and made something that it's supposed to mean. Okay. But I mean, that's nothing to do with the actual technical part, but I mean, this is a good conference that looks at some of these issues. And the other very interesting thing is it, so it's basically, how many of you know this? I asked a loaded question. I basically wrote freedom and equality and said, how many of you know this? But, but what I'm saying is, it's like motherhood and apple pie. People think they're sort of, oh, they're both kind of similar. But you guys are old enough and smart enough to know that freedom and equality are orthogonal issues, right? They're orthogonal dimensions. Sometimes there are societies which focused on equality at the cost of freedom. The entire communism dream has been try to make the society equal. And before they got screwed up, etc., the idea was make the society equal. And since people don't want to be equal, you make them equal, so you're removing the freedom. And the other is we take freedom as important and equality, let it fall where it may. Right? You know this. In fact, what's this guy's name? Alexis Tocqueville. How many of you know that name? You guys, some of you should know more of this than me because I'm just a STEM weeb, right? So some of you are actually coming from humanities. Alexis Tocqueville, actually, I don't even know. He's a French guy, so I am sure I'm saying his name wrong. But he came to US at the time of the beginning of US, and basically, it was like the first democracy, as you guys know, first large-scale democracy after Athens at the Greek time. And so he was essentially trying to write about how the US democracy works. Because, systems in Europe are all feudal. And, they're kings and they're queens and all that stuff. This is one place where they started by saying we're all equal. They don't really mean it at that time because all men are equal. Women are not equal, and not all people are men or women either, because if your color of your skin is not right, then you're not counted. Okay. But even with respect to the all men are created equal, there are all sorts of interesting issues in practice. And Alexis Tocqueville basically was talking about, how the freedom versus equality plays out in a democracy, in a dynamic, vibrant democracy like USA. Because up until then, they didn't have any big democracy going. And it's very interesting study. The reason I bring that up is accuracy versus fairness. Those are also orthogonal dimensions. This is where we talked about it in one of the classes about let X guilty go free, not a single innocent be punished. What is the X? Deciding that X is going to decide your trade-off between accuracy versus fairness. And one of the interesting things is people have shown, this is for actually more from a computer science perspective, computer science algorithms perspective. That under certain conditions, you can't optimize both at the same time. There is no such thing as optimize accuracy as well as fairness. This is what we would like to believe in, right? It's actually theoretically impossible for reasonable definitions of fairness and accuracy. So there is that problem too, that there are some theoretical impossibilities, just as it's not actually clear how to get full freedom and full equality at the same time in a society. I mean, if you figure it out, you basically can get a Nobel Prize, because nobody has figured out how to get both freedom and equality at the same time. Right? It could be that you didn't try hard enough. That's why you get a society that you have. or it could be that the problem was hard to begin with. And in trying to come up with classifiers that are both accurate and fair, that means not biased on any particular subset of people. Do you understand that point, right? That, if I have, let's say 100 people, 80 are white, 20 are black, and I have a system that basically, is being used to decide some property of all these people. It can have differential accuracies. It may have an accuracy on the entire population, but its accuracy on a subset might suck. Okay, and fairness is about whether the accuracy of this classifier on both subsets is similar as against just the entire set. And in trying to make it as equally accurate on the smaller subset as the larger one, you may sometimes wind up having to give up on accuracy. Okay, so it's so much simpler to have this discussion saying AI systems are a problem, everything else is normal up until then they came, but that's not the reality, because in some sense they add to the fire. They didn't start the fire, but the fire was going on and they added a little more fuel to the fire that's going on in terms of societal impacts and biases. And so you can't answer this question without looking at the bigger picture. And if you don't believe me, actually, this is AI and bias is like a radioactive topic to talk about, especially on things like Twitter, right? Because Twitter normally, for everybody who understands what you're saying, there are 5 people who misunderstand what you're saying. That's just irrespective of what you say. And every once in a while, there are just religious wars going on when somebody says something. So there's a thing that actually I'll send you if I can. That was just like 3 months back during summer on Father's Day. I remember it was on Father's Day. There was this system. This is also a beautiful example. I wish I can remember the system. So what it was doing was, if you have a low-res picture of your face, because you took it with a cheapo camera, you want a high-res 4K version of it. Do you understand what I'm saying? Okay. That's a reasonable question. I mean, it looks like AI system should be able to do it for you, because all that we are talking about is a low-res basically is, has very big pixels. And a high-res version of that basically will split it into, there are more pixels, and you should be able to figure out what the values should be for all those pixels, such that the picture still remains the same, but it looks high-res. Do you understand what I'm saying? You all know SD versus HD, right? So back around this time, I forgot the name. I wish I almost need like an extra TA hang around with me when I'm saying this. They should be able to bring it up on the internet, because I can do it myself, but might lose my flow. So this system, what it would do is, it would take any picture, and using similar ideas like GAN idea that I mentioned, it will interpolate and make the picture have more pixels than it started with before. And it actually works quite well. It actually works quite well. Except somebody made the mistake, they were troublemakers on Twitter, right? So here is this nice thing that you give it Donald Trump's picture, it will, make even higher resolution version of Donald Trump, if that's the sort of thing that makes you happy. And they did some more of these examples, and somebody basically said, and they made this system available. Somebody gave it a low-res version of Barack Obama picture. Out came a high-res Barack Obama who was significantly whiter. You see what I'm saying? Significantly whiter. What was happening is that the system, what it was doing is it figured out that you think about this, the kind of grafting, the missing pixels, they're trying to get a distribution of what those pixels would look like. For that, they need to learn how these pixels would look like in normal pictures, for which they saw a huge number of white faces. Do you understand what I'm saying? And then it worked fine for white faces. Just imagine, you got scraped, and I am a plastic surgeon, and I have skin grafts that I can put on your face. But most of my skin grafts are brown. So after I treat you, you look significantly browner, which I think actually makes people look cuter, but you may not think so, right? So the interesting thing was Barack Obama became whiter, and people basically started saying, look, we've always been telling you AI is biased. And notice exactly what happened here. Okay. And when that thing happened, this guy, Jan LeCun, he's one of the guys, well-known guy who did this convnets, which is actually the technology that has been used until very recently, even now, for image recognition. He used to be on the, Twitter, basically, he still is on the Twitter, but that was almost a watershed movement. So somebody was saying this AI is biased, and he just basically said, no, AI is not biased. Data is biased. That's all he said. That's what I said to you too, right? I didn't say it on Twitter, so I'm saved. I'm only saying it to you, and you're all dutifully muting yourself, so you're not yelling at me. And whereas after he just said this, essentially he was like castigated. There was this huge back and forth where pretty much everybody, depending on which way you look at, essentially everybody just piled on. I mean, internets have, Twitter has pile-ons, right? I mean, if somebody is actually in trouble, then everybody else will continue to criticize them. And this is the usual thing. And so there was this huge, controversy. And then in fact, because anything anybody in AI says, even on Twitter, is newsworthy. So there were news articles written about this. So I will send you that later. Okay, so the reason I'm bringing this up is like two issues. One is bias doesn't just come in classification, thinking that cats are dogs, kind of a bias error. It can also come in imagining new pictures. It can come also in interpolation of existing data. It can also come in generating text. We talked about examples of completing a prompt that GPT-3 does. And typically it tends to complete it based on the text that it has seen. And it oftentimes winds up completing it in pretty awfully egregious ways. If you give hot button prompt words. Okay, that's one point. The other point is talking about bias in AI systems has become a lot more tricky because, in fact, one of the ways this whole discussion was going on there was that there were some people who are very respectable in their own work in this area who took the stance that you can't say that it's not my problem. I made an algorithm, it's not my problem. And that algorithms have values inlaid in them. And you cannot actually give yourself a clean sheet without looking at the entire societal structure. That is a fair point. I mean, there are some people who actually, seriously view these issues from that perspective. Some who view it as this is a technical problem with some potentially technical solutions. Some who just completely ignore the whole thing and let's just make money by making a system. And all of those are possible. Any other comments? Did somebody find that system that I was telling you? You didn't, okay. Yeah, actually, in fact, it's there. I actually wrote this. There is in the third page, I mean, it's not in a page. I mean, it says, improve a low resolution picture by upsampling it. There is a sentence in my article, and you click on that, you'll get that particular system. And that's the background. I mean, that system existed, and I'm talking about the huge controversy that erupted around that. So basically, pretty much anything you learn from data can have inadvertent biases. And the problem basically is because we have no idea what the system is learning. And whenever you think about it, think about school bus, ostrich. Do you understand what I'm saying? That should be the thing you should think of. And what would my ostrich school bus say in this case? Remember, I showed you that school bus and ostrich, right? Right? You were very happy when your system said, this is school bus. But then you gave another school bus, which is also a school bus, according to us. But the system thought, even with higher confidence, that it's an ostrich. Do you understand what I'm saying? So it's basically all it is trying to do, all these systems are trying to do is based on, now that sort of gets you to the second part of the thing, hopefully slowly, is given a huge number of pictures and their labels. It basically starts with some big neural network, with large number of weights and so on. And then it's putting the image on this side. And, you initialize the weights correctly, initialize weights randomly first. And then for each image 1, you put it in, it will say class 7. Class 7 may be cat. And then you might say, no, it's not class 7, it's class 9 is the correct answer. Class 9 being, let's say, dog. Then there's an error between what the system said the class is and the real class. And that error is propagated back. Error is propagated back through this network, changing each of the weights a little bit. And all that process does is, on the average, the error is minimized on the data that you have shown it. But did it actually learn anything useful or not? Is not guaranteed. And to make that point very nicely, I will give you 2 examples. One is tanks, the other is the dermatology. So the tanks example is an old example. So here's a story. At one point of time, remember I told you neural networks technology existed for quite a long time. It used to be there in 60s when I was born, and then in 80s it became popular again, and it died, and it again came back in 2000s. So in 80s, 90s, when it was popular, there was this apocryphal story that the Defense Department essentially heard that these neural networks are good at looking at the pictures and finding out what is in the pictures. Then they decided, we have this problem oftentimes when I take a picture, when we take pictures of drone pictures or something. Those days there were no drones, but aerial pictures of some vegetation, we can't quite tell whether the vegetation behind the trees there are tanks hiding. You understand? You would like, if you're a military person, you would like to know if behind the trees there are tanks hiding, right? Because that way you can actually kind of get onto the enemy's case. So they asked some AI guys, here are, why don't you solve this problem? So the AI guys basically need data, right? So the data would be pictures. In some cases, those pictures have tanks in the back of the trees. In some other cases, the pictures have no tanks in the back of the trees. From the picture, you can't tell. Do you understand what I'm saying? Okay. But in these days, first of all, even today, finding that kind of data is hard. But in those days, they actually had to laboriously get the data. So the idea is that they essentially took, pictures one day with, just normal trees, the other day with the same trees with tanks hidden behind them. I mean, you might be thinking, what the heck were they thinking? Why do you expect the neural network to know what you don't know? When you see the picture, you cannot tell whether there's a tank behind the tree that you can't see. So why do you expect the network to know? But one of the problems is people think that networks will know everything because they have a lot of weights, which is the reason why somebody was saying, right, network will be shown your face and the network will say, yeah, don't hire this guy, not a good interview candidate. Okay. And in fact, I told you of systems which are trying to actually figure out whether somebody is a criminal or not by just looking at the face too. It's true that we can't do it, but maybe systems can do it. So coming back to my tank example, they got a data set, training. So they got a whole bunch of data sets of 2 sets of photos. Photos set P1, only trees. Photos set P2, trees plus tanks behind. Okay, maybe there were like 1,000 of these pictures, 1,000 of these pictures. And then they took 800 plus 800 P1, P2 pictures in the training, and they kept 200 and 200 for the testing. Okay? And they trained a neural network. And they tested it on the test data. It got 100% accuracy. 100%. This was in the 80s. So obviously the Defense Department was very impressed. This is the kind of technology we need. I mean, these Russians are never going to be able to hide their tanks anymore. So they wanted to see how complex is this network. Because after all, this is something that we are unable to do, but the system did it. So they wanted to interpret what the system is doing. And so they opened the network and they found that it was only asking one question. The network was only asking one question. Average intensity of light in the picture. That means, is the picture bright or dark? And if it is, and that's the only question it was asking. And basically it was saying, dark, yes, tanks. Light, no tanks. Okay. Do you get any, can anybody guess what's happening here? I mean, these are real pictures. They gave pictures and they trained it. And the system worked on the test data.
The only photos they had with the tanks were at night. All the photos they had with no tanks were in the day.
Very close, basically. I mean, the way the story is told is they basically, they took the pictures on 2 different days. Now, one day they put the tanks behind the trees. The other day they didn't put the tanks behind the trees. The day they put the tanks behind the trees, it was a cloudy day. The day they didn't put tanks behind the trees, it was a sunny day. What is the system trying to optimize? It is trying to optimize the error between what it said is the class. The class is yes tanks or no tanks, and what the real label is. Do you understand what I just said? So if the system did not do it, it's a stupid learning system. Because this is a shortcut for solving this particular problem. Because all you are saying is optimize on the test set, and the test set was on this. In fact, had they really looked at pictures from Russia that they didn't take, it would have failed. It would have basically been pretty bad. But mostly people do it this way. They get a bunch of data, split it into 2 pieces. They train the system on 1 piece, test it on the other piece, certify that the system is now working, just like the way gender shades, the gender detection systems were certified, just like the way the Samsung blink detection was certified. And then they'll put it in the wide open world and you deal with the problem. Okay. Just as much as you should remember the adversarial school bus, the school bus and ostrich, I'd like to think of it as the adversarial school bus. This tank example is also very important for you to remember. Okay. Tank is also very important to remember, because these things are called, remember what I said, ML systems learn correlations. All they learn is correlation. You can have spurious correlation. If there are spurious correlations, the system will learn them. Because it's getting points for being right, not for making sense. Do you understand what I just said? Now, this is 1980s example. You obviously do, you would think that Rao just made this up just to make a huge point about some old stuff. So I'll tell you now about, I will give you a link to it too. There was a paper in Nature. How many of you heard of Nature, the journal? Yeah, it's considered, like, for biology dweebs at least, it's considered like the top of the world journal. Okay. It has its own problems because it's actually a for-profit journal. Some particular Springer publishes it, etc. But anyway, getting a paper in Nature is considered like very prestigious for all the biology dweebs. So there's a paper last year in Nature which essentially which analyzed melanoma detection systems. by detection by neural networks. You guys know melanoma? You have heard of melanoma? Okay. Actually, I vaguely remember. I don't even know whether I have it anymore. There used to be like a little dark spot here, and I looked here, looked there, and essentially decided it looks like melanoma. Probably my days are numbered. So then I made an appointment with the top dermatologist in Phoenix, and I went to see him. After like 20 days or 30 days, and the guy came in, took a look at it, and then went away because he could see that what I had was not at all melanoma. And so the rest of the time, since I already paid for the visit, I looked at the beautiful pictures that this guy took of all his travels in India and other places. I still remember that. The reason I'm bringing this up is, I had to spend money, good money, to get this melanoma diagnosis. Imagine you have like on the web, cell phone, right after Gmail, there is a melanoma app. And then you just put it on your face. Especially in Arizona, it's very important because a lot of us basically are hanging around in the sun and we can get melanoma. Okay. And so it can diagnose melanoma for you. Do you understand what I'm saying? So in fact, there was a particular paper that was highly cited that was extremely good at recognizing skin blotches as to whether they are melanoma or not. You heard these kinds of stories all the time, right? I mean, AI diagnoses, COVID, AI diagnoses something else. Basically, AI is good at looking at pictures and making classification right now. What can go wrong? Obviously, it was expert level. It was doing at better or, equal or better than the experts in diagnosing, checking whether or not a particular skin blotch is melanoma or benign versus malignant melanoma. That's what it was good at doing. Looks like this is AI for social good, right? I mean, this is the kind of thing that you want AI. So what these people did in this Nature paper is actually looked at the Nature dermatology. I will send you that picture. What they did was they looked at the data on which the system was trained and tested. Basically, people, you may have laughed to yourself thinking, who are these bozos who, in trying to figure out whether they're tanks or not, they actually take pictures, made up pictures of with tanks, without tanks, right? That's how it's done even now. Okay, so what these guys did essentially is they took images of real patients who came for melanoma diagnosis. And they knew for each of them, the experts told them whether or not that was melanoma or not. Okay, and it was doing extremely well. And so people look just like this tank situation. They decided, what is the system looking at? What is the system looking at? And it turns out what the system was looking at was like this. Imagine, there's a photograph of like something like that. That's a splotch. And there is some sort of a arrow. It was looking for that arrow. Now, can you guys guess what happened? I mean, can you imagine if you get melanoma with an arrow and then all you need to see is the arrow, right? So what do you think happened in this case?
I think the doctors had already made a diagnosis and then the machine was just looking for the arrow.
Exactly. So what happened is that the data that they collected was from real hospitals. In the real hospitals, the ones you know, like my kind of cases where I go in and I say, go away, they are like totally not at all melanoma. Okay. Then for others, they will put an arrow saying, take a better look at this on the picture. And they picked up that entire data. They didn't think that, you know, it's not that the researchers were trying to cheat. They just took the data that was available. And the available data had an unexpected spurious correlation. So that's what the system was picking up on. So as long as you go to the doctor with an arrow, I mean, your AI doctor with an arrow on the thing, it will say, yeah, you are almost dying. You know, whereas it'll say, even if you had real melanoma, it says, looks, you're fine. And why was this not figured out before? Because they took the data, split it into training and testing. It's from the same data. The test set was not seen, but it came from the same distribution. Okay, this is the other word you have to say. Training and testing data come from the same distribution. And it needs to happen. Machine learning systems can't learn unless the new things are coming from the same distribution as the training data. Except this distribution, unbeknownst to you, had this really, really crazy, spurious correlation. You may not have noticed it, but your system will notice it because all it is doing is trying to minimize the error. It doesn't care whether the hypothesis it is generating makes any semantic sense in the real world medicine. You are laughing because you know that melanoma doesn't come with or without arrows. Because you apparently have this common sense. Somehow you never saw, you know, your friends walking with arrows on their, you know, skin blotches. But what is this system to know? It just knows the data that was given to it. Do you understand what I'm saying? The reason I bring this whole thing up is this all came from the fact that we don't know what the systems are learning. Oftentimes, we only know that the systems are working. But this working is a iffy concept. Did you check? I mean, Samsung thought their cameras were working because they made the blink feature using the model of Midwest, you know, people with big eyes. And it worked on them. And it was only when they started trying to sell it in Korea, etc., they got into trouble. Then you can tell them that, oh, you Koreans are out of distribution. But then the Koreans will say, you, the company, is out of Korea. Because why the heck should you be hanging around with us when making stuff that we can't even use? So this word out of distribution, wow. This word out of distribution I mentioned, how many people remember the word out of phrase out of distribution? When did I last say it?
When we were talking about like the different numbers and then you show it a banana and it says
exactly.
It's like a 3.
Numbers and bananas. So you think who will show numbers and bananas to the same system? But you don't think who will show splotches with arrows and splotches with no arrows to the same system. But the system says, hey, every time else you gave a nice little arrow. Do you understand what I'm saying? By the way, we do this, right? I mean, there are these things like they talk about poker face versus face with tells. So some people don't know how to put a poker face. So they get a good set of cards. They start basically they don't show a neutral face. They don't show a neutral face. And so from their face, you can tell whether their cards are good or bad. We do this. It's not that the face caused the cards, but the face expression is correlated with the cards because the tell is there. That brings me to another very interesting point. If you are learning a binary category, for example, tanks versus no tanks, or melanoma versus no melanoma. That means all you are trying to, you give a data and this thing has to say yes or no. That's it. It's a binary category. Okay. So I will give you 3 systems. System 1, system 2, system 3. 3 systems, 3 machine learning systems. System 1 has 70% accuracy. That means if it says it is yes, then it is yes with 70% probability. System 2 has 50% accuracy. System 3 has 30% accuracy. You understand what I just said? It's a binary classification system. Of these, which is the best system, according to you? If you have to pick one system, which is the best system for doing this task?
The first
System one.
What? Who all said it's the first one? Okay. Anybody else thinks otherwise? Okay. So we all agree this is the first choice. I see that the market for this is too high, so I'm going to charge you $1 billion for it. So you can't afford it. So then you have to pick one of these other two. Which is the second best system?
The second one.
How many of you think it is second one? 50% accuracy one. How many of you think it's the third one, 30% accuracy one? Okay, that's Joshua and Man. And who else are saying the third one? Okay. Why does Joshua go against the wisdom of this crowd? What is he seeing that you guys are not seeing? You realize 50 is bigger than 30, so you went for 50. But it turns out Joshua is actually right. Why?
Is it because for the second one, it's a 50-50 chance, whereas the other one, it's a 30-70 chance of 70 of not right? So the not right could be classified
So you
as
buy
right.
that system. Is that what Joshua was going to do? You're just going to buy the system, which is going cheap, and just do exactly what opposite of what it says is the right answer. How hard is that? It's only a binary class. Whenever it says you have melanoma, I say, oh, I mean, I don't have melanoma. Do you understand what I'm saying? So this is actually a very important point. The worst learner is, for a binary concept at any rate, for a binary concept, is the 50% accuracy one. It's very important to understand. It's better to be egregiously bad so that I just do the opposite of what you're saying and I'll be more right. So the equivalent of this is kind of saying a clock that's stuck is right at least twice a day. Whereas a clock that is 10 minutes fast is never right. Do you see what I'm saying? So the point being that actually it's very important to understand. This is why people say that 50 plus epsilon learner. As long as the epsilon better than 50, you are giving me something. 50 is the worst learner for a binary concept. That's clearly, I don't know, whatever. That's the whatever kind of learner. So if you learn exactly the opposite of the right answer, you learn something. At least after a while, you'll figure out, looks like I learned the opposite of what is the right thing to do in the life. I'll just then go against my instincts. In fact, I don't know, I mean, did I mention Seinfeld in the beginning of my thing? And somebody even said that they saw a Seinfeld. Somebody said, is anybody still here who actually has seen Seinfeld? Okay, so George Costanza once says that, remember, if every instinct you have is wrong, then opposite of our instinct should be right. So then he will start doing everything opposite to what he thinks he should be doing. And he does extremely well in that particular episode. That's exactly what we are saying. So in fact, you know, a learner that has on a binary classification 0% accuracy is amazing, because the negative of that is 100% accurate learner. Okay. Useful to remember. In fact, it is connected. This can be generalized to any number of classes. So for example, if I'm about to cast a die, 6-faced die, you know the one that the dice that we throw, and you're supposed to guess what it will come as, right? Basically, something which guesses with 1/6 probability is no better than you doing the dice yourself. So if somebody is actually telling you something, then they need to be able to change it in such a way that it's more like this. So some things have higher probability. And so this idea is actually, I mean, this is just throwing in a word at you. This idea is called entropy. And on a six outcome category, the worst classifier is the one that uniformly, with a random probability, 1/6 probability, says it's this class or this class or this class. Anything, and because that would be the uniform random guess. Anything else is essentially better than this uniform guess. I mean, it has lower entropy. And if you have lower entropy, then oftentimes you can use it to your advantage. Because, as I said, if it is negative of the right, then you can do the negative and then get higher accuracy. Okay. Any other questions? I'm not even sure how we slowly got into this, but I think this is an extremely useful thing. Again, each of these little pieces, this is almost common sense. And you can actually check whether the bozos that tell you that they are AI experts are actually AI experts by asking these sanity questions. Okay, this is common sense, but it's not obvious to you, right? I mean, again, common sense is only common sense after you acquire it, right? A lot of you did go with the 50% accuracy one with binary classification. It's useful. Even though I saw your faces, nobody else has seen it. Next time onwards, you know, as long as Joshua keeps his mouth shut, we all were right. We all knew that 50% is the worst learner. We are not going to buy it. 49% is better. 10% is even better. But the other thing I said is all learners are doing is essentially optimizing this error reduction. And if they can do the error reduction by exploiting the spurious correlations, they would do it. For some very strange reason, I remembered Lincoln's statement, Abraham Lincoln's statement, that all I want is to keep the Union together. If I can do it with slavery, I will. If I can do it without slavery, I will. If I can do it with part slavery kept, part slavery not kept, I will. Do you understand what I'm saying? That's what a learner is saying. It has an objective. The means are not important. You are adding semantics after the fact. And that's when you fall on your face. Because in fact, the learner might have learned something completely nonsensical. So the other very tricky point is that, I don't know actually if you know this, there are all sorts of very syntactically complex ways of saying simple things, right? Tell me one. I mean, somehow I'm remembering this. For the dweebs who remember imaginary numbers. This is the way to write 0. Because e power I pi is -1, -1 plus 1, 0. Do you understand what I'm saying? Okay, so you would think Rav is telling me something very useful if I write this way. But if I say 0, he's just give me 0, what's the big deal? So in fact, if I give you like e power I pi plus 1 as your score on the exam, you might feel much happier than getting a 0. But, but I was basically pulling your leg because I just wrote a syntactically complex thing, which is actually 0. That winds up being important for all these neural networks too, because if you are actually searching in a smaller configuration network, it might be easier to figure out that all it is doing is to look at the average intensity of the picture or the arrow in the picture. But remember, a network basically has the same number of weights. It might have 13 million weights. And it has figured out a 13 million sized function, which is saying, look at the intensity. Do you understand what I'm saying? So you can be very, very, very easily misled just from the unnecessary syntactic complexity of the network. I just gave you the stripped down version where you can easily figure this out. In fact, one of the things that then people are doing in this case, so the tank example, I almost can say, if you just used a very simple network, that's what they were doing, and they were able to figure out that it was only looking at intensity. But for the dermatology example, it wasn't at all obvious. What they had to do is they had to ask the system to show the saliency region. That means it is, you show this and, you have a thing like this, right? And you're asking the system, can you tell me which pixels in this picture seem to make a difference in this being a malignant melanoma? You can do that to the systems, and then the system will blithely show you, obviously this man, look at this. This area is giving me all the information. Then you say, gotcha. In fact, I wish I can show you this other example. There is another example where a system learns Alaskan Husky. So there are many, many categories. So you show, I wish I had that picture, I can show you later, but so it basically you show the picture of this dog and it says Alaskan Husky. Wow, that's pretty impressive. I mean, that's what they've been telling me, that AI is impressive. Then you ask, tell me which part of this dog did you think makes it Alaskan Husky? That means just show me the pixels that were more important for your decision. And it will nicely show you the snow on the ground. So you take your Labradoodle or your whatever dog and put it on snow. The dog may not be happy, especially if it's a Tempe dog. The system will say, great Alaskan Husky. When it is right, you are impressed. When it is wrong, you say, just a mistake. I'm sure next time around, AI will be right. None of these are made up. In fact, I wish I can show you. This is why I think I need somebody as soon as I say this is what happens in the real TV shows, I think. When I'm saying this, somebody else will then produce that and put it on the screen, because I actually have it on my own talks. I wish maybe I can show you that. Maybe it is there. But, it's a, let me see actually if I can see that. I show this around typically. Unfortunately, don't. Yeah, I'll show you later. But this happens in real systems. And then basically, this is why this issue of explainable AI systems have become important. Explainable AI systems sort of try to tell you, here is the reason, here is the class, and this is why we are saying it. So at least you can debug the systems. You can say, Bozo, dogs aren't going to be changed because of snow on the ground. But how does the system know? For it, the snow on the ground is like the intensity in the tank case and the arrow in the melanoma case. When you're able to see all three as equivalent, you have learned a whole lot about how these systems work. Because if you have spurious correlations, you're supposed to exploit them. If you are a learner worth their salt, you're supposed to exploit them. In fact, the last thing I want to remember, again, I don't have the slide for this. I may have mentioned this. In this classic Simpsons episode, this woman teaches the students how to do well. I think I mentioned this in the first class, how to do well in the exam, because no child left behind policy has been instituted. They don't want anybody to fail in the test. So rather than teach them, they prepare them to the test. And being Simpsons, they actually directly go to the jugular. The teacher, Mrs. Krubapul, is telling them, remember this, which is Abba, Kaba. That you just keep saying Abba, Kaba, because most standardized tests tend to have A, B, A, C, A, B, A, according to what she has figured out. So there were a bunch of other lines. And so you remember this poem and then just start writing it. So the question then is, you do well in that exam, did you learn anything? In fact, there's a bigger question. When you guys do well in any exams, have you learned anything? I don't know. Okay, there is this question of people want to see, I would like to believe that you got your A because you learned something, but you could have just optimized for A. And in this university, you won't get caught. In the real world, might be, you will get caught. And then you can say out of distribution. I'm supposed to only do this in the class, and you can't ask me to do this when I'm outside the class. And we do this. We are also learners of that kind, except we tend to at least have a better idea of common sense connections between things. And so you are not likely to make the mistakes that AI systems are happy to make, that the arrow is connected to melanoma. Okay. It's 4:03. I actually wanted to teach you something more. I obviously can't, but remind me next time. I think I want to teach you about Newton-Raphson method. You can look it up. Newton-Raphson method basically is a method which, if you have a function, I'll let you go very soon. If you have a function, you are trying to figure out, this is the function f x, you're trying to figure out what are the values of x for which f of x equal to 0. That is the zero crossing of the function. This is what you call normally equation solving. But if I know, for example, the function is x plus 5, then you know that the value of x for which x plus 5 is 0 is x equal to minus 5. You also know this for things like x squared minus 2x plus 3, because you remember this minus b plus or minus square root of b squared minus 4ac by 2a, that you remembered as the quadratic equation solution. After that, you don't know anymore. Any arbitrary function I give, which is sine x cubed plus 3x squared plus 4 log x, is this function here, where will it hit 0? If it hits 0, how will you solve this equal to 0? And Newton-Raphson method essentially says, starts anywhere. Let's say here, x 0. Take the tangent there. The tangent will be f dash x 0, the slope of the tangent. I'll say it again later, but slope of tangent is f dash x 0. So see where the tangent is hitting x-axis. That is going to be your new x1. So x1 is set as x0 minus f of x0 by f dash of x0. F dash is the gradient, is the derivative. And we will talk about this, and this is actually the basis for gradient descent. Because in the gradient descent, all you're doing is you have a function f dash. You know that any arbitrary function, you're trying to find the minimum, the error minimum. The minimum of the error will occur when f dash becomes 0 from calculus. And so that means now I'm going to write, for f dash function, I'm trying to do Newton-Raphson method. And to do that, I will just say, I'll start with x0, and x1 will be x0 minus f dash x by f double dash x. This is gradient descent. And I know this is last minute throw on you, but I want to get back to this and explain to you so that you have a sense of what is the engine that makes these learning systems work. This is very simple calculus. Okay. Anything else that you want to bring up other than please let us go? Okay, so those of you who may not have realized, right after the class, I put an instant poll. Some of you are taking part in it, some of you are not. It's all completely optional, but it'll give me a sense of what is going okay for you, what is just killing you. Okay, it's sort of hard to tell, especially if you put a nice poker face, whether or not it's going well. But you can use that, and you can also give me other comments anyway through the survey thing. So that's what we will end at, and I will figure out what we'll be discussing in next class. But I'm surprised that you guys didn't bring up too many bias worries. I seem to have thrown in all the things that I wanted to throw, but I felt as if there was like a lot of interest in talking about bias, but apparently it's also semester is ending and maybe you have too many homeworks or something. But we'll get back to this. Okay.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.